So 5.2 wants us to prove the following identity. We can start by just copying it down. So identities aren't something that you can magically get good at. They are a process of trial and error. Although it's not completely like gambling, there is some degree of luck to it depending on which identities you use. But also that luck has some degree of self-control, so or self-influence, because the more you do, the more you recognize patterns and the more you get good at manipulating trig identities. So you only know what to use when you know what to look for, and you know what to look for when you see it a lot of times. So the trick is always practicing, finding a lot of materials, and just generally doing a lot of these sums. So here we're trying to prove that the left hand side is equals to the right hand side. So I'll just take this and work with this one side that we have. So this is my left hand side, and I want it at the end hopefully to write some equation and say eventually this is equal to the right hand side. So we may begin. Now let's notice what we're trying to prove. We're trying to prove that it's equal to tan or 2 tan 2x. Now of course there's a variety of ways that we could approach this problem, but at the end we know we are kind of looking for sine 2x over cos 2x multiplied by 2. 2 can be there, it can be there, it doesn't really matter, but we know we're trying to go for this. So generally on the top we should be trying to create a double angle for sine. At the bottom we should be trying to create a double angle for cos, or we'll see how it plays out, but this is how you spot patterns and can help yourself reduce the amount of work you need to do. So let me not actually erase that. And first thing we can do is, we see here we have two fractions, but here we only have one term. Two terms, so we need to combine this. How do we combine it? This side is cos minus sine x, this side is cos x plus sine x. So we know the common denominator will be cos x minus sine x, and then cos x plus sine x. So that means on the top part I'm gonna need more space, and maybe let me make that straight. Okay, so on the top part we're gonna multiply what we don't currently have. So what we have is cos x minus sine x. That means we're gonna multiply the top by cos x plus x, and there already is a cos x plus sine x. Cos x plus sine x. So now it's going to be multiplied by another one, so we can just put a square on that, minus cos x minus x. Same thing with this, we can just put a square on this one since it's being multiplied by the same thing. So now that we have it like this, there isn't much we can do. So what we're gonna opt for is to multiply out the numerator. So we're gonna take our numerator and we're gonna FOIL on each bracket. So the first part we're gonna have cos squared x, then we're gonna multiply these two and multiply the result by 2. So it's gonna be 2. Let's start with sine x cos x plus sine squared x, and then we're gonna have minus another bracket. So this one's gonna be cos x cos squared x minus, since we multiply them together we get minus sine x cos x multiplied by 2, it's minus 2 sine x cos x. and then multiply sine squared x at the end, you get plus sine squared x, and then this is all over the same denominator that we have, but we can simplify this, because what do we see here? We see cos x minus sine x and cos x plus sine x. Where do we usually see something like this? So this is usually seen in x plus 2, x minus 2. This is what you have is difference of two squares. If you take x squared minus 4, it will give you this if you factorize, and if you simplify, it will return this value. So here what we're gonna do is we are gonna multiply out basically, but we already know that it's gonna result in cos squared x minus sine squared x. So that's the difference of two squares. Then over here, let's see what's gonna happen so we avoid writing too many terms. We have a positive cos square x and a positive cos square x here, but there's a minus right there. So this is gonna cause those two to cancel. Then there is a positive sine x, sine squared x, and a negative because of this. And also this one, that's what happened. So these two also cancel. Then that leaves this minus and that minus. That's gonna make a positive. So at the end we're gonna have this term and this term being added together to give us 4 sine x cos x all over cos square x. Actually, we can replace cos square x minus sine square x with cos 2x. Then what I'd like to do for my next step is I'd like to write 4 sine x cos x as 2 times 2 sine x cos x. In case it wasn't visible before, this is an identity on the top part for the double angle of sine. So that's going to be 2 times sine double angle over cos double angle. Then this is going to give us 2 times tan double angle, and that is equal to the right hand side as we were trying to prove earlier. 2 times, yes, 2 times tan 2x. So here I'll just hint out the identities that I used. So over here I used the identity for cos square x minus sine square x is equal to cos 2x. And then over here I use an identity for 2 sine x cos x is equal to cos 2x. And then lastly, this is just an identity for sine x over cos x gives us tan x. So that's the list of all the identities I used here, just this common 3, and we have proven our identity.